Hey everybody, Mr. Quick here. Today we're going to be looking at Eureka Math / Engaged New York Math, Module 4, Lesson 20, Writing and Evaluating Expressions. Today we're going to be looking at multiplication and division. The last few lessons we've been doing basically the same thing and using tables and looking at addition subtraction problems. Today we're just taking it to the next logical step, which would be to create and evaluate, meaning solve, for multiplication and division problems. Let's go ahead and get started. Okay, I'm going to read this example for you. In New York State, which, side note, you realize Engaged New York is a math curriculum that comes from New York. That's why New York is used for a lot of these examples, because that's where it comes from. Okay, in New York State, there is a 5-cent deposit on all carbonated beverage cans and bottles. When you return the empty can or bottle, you get 5 cents back. So, if you drink a can of soda and then you go return it, you get 5 cents back. Complete the table. All right, so number of cans, or number of containers, because it can be bottles too. Number of containers returned. We go 1, 2, 3, 4, and they jump down to 10, 50, 100. So they're just showing you the different numbers of containers that you could return. It wants to know what the refund would be for each number of those containers returned in dollars. Now, it didn't just say refund, it says refund in dollars, because they need to know how much, is it refund in cents? Is it refund in dollars? What is it? So they're very specific there. So if you return one can and it's a 5-cent deposit, you get 5 cents back, then you're going to get $0.05 back, right? That's 5 cents. That's 5/100ths of a dollar. So one container gets you 0.05. How many would 2 containers get you? Or I should say, how much would 2 containers get you? Well, if you're going to get 2, it would be this amount times 2, right? So if you're getting 5 cents for one container, you'd be getting 10 cents for 2 containers. For 3 containers, I think you're starting to see a pattern here, 15 cents, right? So 5 cents per container, 5, 10, 15. What about 4 containers? Well, 4 containers, 5 cents each, 5, 10, 15, 20, you'd be looking at 20 cents. Now we've jumped down to 10 containers. Well, if our pattern holds true, then basically we're looking at 1 times 5 cents. Let me make that look a little better there. Times 0.05. 2 was times 0.05. 3 was times 0.05. So we're starting to see a pattern. The number of containers returned times 0.05 gives us or we'll just say our refund, right? So, following the same pattern, we're looking at 10 times 0.05. I know that means if I'm going to multiply by 10, I've got to move my decimal 1 place, right? 1 0 move. And then, or 1 decimal move, I should say. So we end up with 0.5, which is, you can add a 0 after that, right? So it's 50 cents. What about 50? Well, we can say 50 cans times 0.05. I have 2 decimal moves to get rid of the decimal, so I'll put that up in the top here. 5 times 0 is 0. 5 times 5 is 25. I can do the next line. I see it's 0, so I know it's going to be all zeros, right? Add a 0, happy face 0, placeholder 0. 0 times 0 is 0. 0 times 5 is 0. Subtract, of course, we get 250. We have 2 decimal moves to go back in. 1, 2. So we end up with 2.5. So for 50 cans, you get 2.5 or $2.50. For 100 cans times 5 cents, or 0.05, I'm having 2 decimal moves because we have 2. We're starting our number in the hundreds place. So 2 decimal moves, 1, 2, would give me 5 point, and you could fill in with zeros, so $5. So as you see, each time we're doing this number times 5 cents. So if this number is C, meaning we don't know what number it is, but we want to have an expression, we would have C times 5 cents, and we know we can't put the letter first, so we put 0.05 times C. This is the expression we've used every time to solve all the problems on this board. So here we're looking at the same, basically what we just answered, right? 0.05 C. Now, it says for part C here, use the expression to find out how much money Brett would receive if he returned 222 cans. Well, we're going to take 222 times 0.05. I'm going to take the decimal out of it. So I've got 2 decimal moves, 1, 2, to put it at the end. 5 times 2 is 10, carry the 1. 5 times 2 is 10, plus 1 is 11, drop the 1, carry the 1. 5 times 2 is 10, plus 1. There we go. I know I don't need to do the next line because it's all zeros. So 2 decimal moves, I've got to go back in 11.10 or $11.10. So he'd receive $11.10. Now for part D, things get a little interesting. It says, if Gavin needs to earn $4.50 for returning cans, how many cans does he need to collect in return? Well, now we're not multiplying because we don't know how many cans it is, right? We don't know how many cans there are. So we're going to have to do the reverse of multiplication. We're going to have to divide. So we're going to have to take $4.50 and divide that by 0.05. Now, I'm going to show you kind of the trick to doing decimal division. When you have a decimal on this side, you can't do it yet. You've got to move it twice, which essentially is going to give you 5. But since you move the decimal twice to the right on this one, you have to do the same thing over here. So we're going to move this twice. So basically, now we have 450 divided by 5. 5 goes into 45 9 times. 9 times 5 is 45. I subtract, we have 0. Bring down the next 0. 5 goes into 0 0 times. 0 times 5 is 0. We subtract, we get 0. We could keep going, but we just have to put a decimal and decimal, keep doing zeros and bringing them down, and it would just always be 0. So he would have to collect 90 cans. How is part D different than part C? Well, part C we used our expression and we multiplied. Part D, we couldn't use our expression, but we knew however many cans he has times 0.05 gives us the answer. Now we knew, hey, we know how much money he's going to get, so we have to figure out how many cans he would need. So it's just in part C, we were using multiplication, and in part D, we were using division. We were going backwards. All right, let's look at one more example here. The fare for a subway or local bus ride is $2.50. If you take one ride, it's going to cost you $2.50. If you take 2 rides, then that's going to be $2.50 twice. So I know I'm looking at times 250. That works for this first one also, right? 1 times 250 is 250. 2 times 250 is going to be $5. I can keep going down the line. 3 times 350 would be, or 250, excuse me, would be 750. 4 times 250 would be $10. 5 times 250 would be $12.50. Was taking that $2.50 fare and multiplying it by how many rides you take. So ultimately we have the number of rides as R. We know that our expression is going to be R times $2.50. We would have to write that as 250R because you always put the number first. I'm gonna run out of time if I solve all these, but I'm gonna show you that 10 times 250 would obviously be $25 because you'd be moving the decimal one time. 30 times 250 would be $75. Now, maybe you notice when we had 3 times 250, we had $7.50. 10 times more, right? Same thing here. 10 times more, 750 goes to $75. So what expression shows you the cost of the rides? Well, $2.50 per ride, so $2.50 times the number of rides. All right, use the expression to find out how many 60 rides would cost. So if we're going to say 60 times, okay, so we have 60 rides times 250. Apologize, I have some painters here at my house, so I actually got delayed, so I'm like, where did I leave off here? Okay, so if we're going to do 60 times 250, I'm going to go ahead and move this decimal out of the way. And here's kind of a trick, because I see this is 0 right here. I know that I can just move the decimal one time, and I can do 60 times 25 with one decimal move, because I only had to move it 1 to get it out of the way. Once there's zeros on the right side of the decimal, you're good to go. Now, if you had moved it 2 decimal moves and you did 60 times 250, and then you had 2 decimal moves, you'd still get the right answer. So you're not going to get the wrong answer doing that, but I just wanted to show you that little trick. So we had the decimal between the 2 and the 5, and I moved it between the 5 and the 0, so that was 1 decimal move. 5 times 0 is 0. 5 times 6 is 30. Going down to the next line, so since I'm starting in the tens place, my answer's got to start in the tens place. 2 times, so I put in my little happy face 0, right? 2 times 0 is 0. 2 times 6 is 12. Add this up. I'm going to add it up here. 0, 0, 5, and 1. 1 decimal move. Put it right there. It would cost, oh, I'm on the wrong line here. It would cost $150. Like you see that because my decimal is right there, my answer is 150. Okay? So, part D says that if a commuter spends $175 on subway or bus rides, how many trips did they take? Well, we don't know how many trips, but so we can go backwards. So we can take the $175, divide that by 250, which is the same as 2.5. Move this decimal one place, move this decimal one place, add a 0 here. So now I've got 1,750 divided by 25. Okay, 25 doesn't go into 1, 25 doesn't go into 17, 25 does go into 175. 7 times 150 is 175 exactly. 0, drop to 0. 7 does, or excuse me, 25 goes into 0. 0 times 25 is 0. If I wanted to put my decimals and keep doing it, I would just keep getting zeros. So they would have to take 70 trips to spend $175. Big difference there is we're looking at multiplication, or here we're going the reverse and we're looking at division. All right, I'm about out of time on my video, so I'm going to stop there. I know this is pretty quick, but we're also going to talk about these together as a class, and we'll go through some more examples as well. So I'll see you soon. Thanks for watching.